Now let's look at the second example problem. This is a lead code problem called the subarray sum equals k. So you are given a array of integers and a target integer k, and the goal is to find out the number of continuous subarrays whose sum equals k. So these are the parameter constraints. So there are at most 20,000 array elements. Each of the numbers are in negative 1,000 to 1,000, and the range of k is in this range. So in order to understand this question, let's consider this concrete example. So we have 7 elements, and k is 6. So we want to find out how many subarrays of this array will sum up to 6. So encourage you to pause and think how many are there. So the answer is 5. So there are 5 such arrays. Here is 1, 0, 1, 4, 2. So that sum up to 6. So of course without 1, 0, 1, just 4, 2 also sum up to 6. And 4, 2, negative 2, 2 also sum up to 6. And 1, negative 1, 4, 2, negative 2, this also sum up to 6. And if we get rid of the first one and add the last one, they also sum up to 6. So there are 5 of them. So how do we solve this problem? The first one, let's try the brute force approach. So we just try our subarray and then compute the subarray sum, and then see whether it matches, and if it is, then we increment count. So this just loop over all possible subarrays, and line 4 and 5 compute the subarray sum, and if the subarray sum equals k, then we increment the count by 1. So what's the time complexity of this approach? So the complexity is n cube, because the line that executed the most, sort of contribute the most to the complexity, is line 5. So line 5 itself is executed a big O n squared times. In fact, if you really want to count, it's sort of, I think it's n times n plus 1 over 2 number of times. And within here, the number of times depends on I and j, but overall, the complexity n cube, I think the complexity, if you really want to count how many times this subsum plus equal is executed, I think it's probably around n cube over 6. But the exact number does not matter. So this is n cube algorithm. So how do we speed it up? We try to see whether there are computations that are repeated. So I think for this, it's pretty obvious what computations are repeated. We are repeatedly computing these sums. So we are adding numbers together again and again for each of the sums. So that is one thing that we can try to avoid. So yeah, so the way to avoid this repeated summing is to use prefix sum, which we talk about in topic 1. So the sum of any subarray is equals the difference of 2 prefix sum, because the prefix sum is sum from the beginning to an element. So if we take 2 prefix sum and then we subtract them, then we get this subarray sum. So by doing that, we can reduce the computation complexity. So this is a second take on this problem. We use prefix sum array. So we first compute the prefix sum array by doing this. So in general, the prefix sum array should start with a 0. So the prefix sum p sums I plus 1 equals the sum of all the elements from 0 to I. So prefix sum will contain one more element than the original array. So this is make it easier to calculate any rank sum. So we have a 0 which represents the sum of 0 element in the array. So this line 6 will check whether this subarray sum equals k. So think about what code should go in there. You really have to get every index right. Yeah. So yeah, it's just a prefix sums p sums j minus p sums I. That's checking that whether equals k. So the complexity is n cube. The complexity is n squared. So can we speed this up further?